In this video, I want to do a bunch of example problems that show up on standardized exams and definitely will help you with our divisibility module because it's asking you questions like this. All numbers, and this is just one of the examples, all numbers divisible by both 12 and 20 are also divisible by. And the trick here is to realize that if a number is divisible by both 12 and 20, it has to be divisible by each of these guys' prime factors. So let's take their prime factorization. The prime factorization of 12. Let's see, 12 is 2 times 6. 6 isn't prime yet, so 6 is 2 times 3. So that is prime. So any number divisible by 12 needs to be divisible by 2 times 2 times 3. So its prime factorization needs to have a 2 times a 2 times a 3 in it. Any number that's divisible by 12. Now, any number that's divisible by 20 needs to be divisible by, let's take its prime factorization. 2 times 10. 10 is 2 times 5. So any number divisible by 20 needs to also be divisible by 2 times 2 times 5. Or another way of thinking about it, it needs to have 2 2's and a 5 in its prime factorization. Now, if you're divisible by both, you have to have 2 2's, a 3, and a 5. 2 2's and a 3 for 12, and then 2 2's and a 5 for 20. And you can verify this for yourself, that this is divisible by both. Obviously, if you divide it by 20, let me do it this way. Dividing it by 20 is the same thing as dividing it by 2 times 2 times 5. So you're going to have the 2's are going to cancel out, the 5's are going to cancel out. You're just going to have a 3 left over. And if you were to divide it, so it's clearly divisible by 20. And if you were to divide it by 12, you divide it by 2 times 2 times 3. This is the same thing as 12. And so these guys would cancel out, and you would just have a 5 left over. So it's clearly divisible by both. And this number right here is 60. It's 4 times 3, which is 12, times 5. It's 60. This right here is actually the least common multiple of 12 and 20. Now, this isn't the only number that's divisible by both 12 and 20. You could multiply this number right here by a whole bunch of other factors. I could call them A, B, and C. But this is kind of the smallest number that's divisible by 12 and 20. Any larger number will also be divisible by the same things as this smaller number. Now, with that said, let's answer the questions. All numbers divisible by both 12 and 20 are also divisible by, well, we don't know what these numbers are, so we can't really address it. They might just be ones, or they might not exist, because the number might be 60. It might be 120. Who knows what this number is? So the only numbers that we know can be divided into this number, well, we know 2 can be. We know that 2 is a legitimate answer. 2 is obviously divisible into 2 times 2 times 3 times 5. We know that 2 times 2 is divisible into it, because we have the 2 times 2 over there. We know that 3 is divisible into it. We know that 2 times 3 is divisible into it. So that's 6. Let me write these. This is 4. This is 6. We know that 2 times 2 times 3 is divisible into it. I could go through every combination of these numbers right here. We know that 3 times 5 is divisible into it. We know that 2 times 3 times 5 is divisible into it. So in general, you can look at these prime factors, and any combination of these prime factors is divisible into any number that's divisible by both 12 and 20. So if this was a multiple choice question, and the choices were 7 and 9 and 12 and 8, you would say, well, let's see, 7 is not one of these prime factors over here. 9 is 3 times 3. So I need to have 2 3's here. I only have 1 3 here. So 9 doesn't work. 7 doesn't work. 9 doesn't work. 12 is 4 times 3. Or, another way to think about it, 12 is 2 times 2 times 3. Well, there is a 2 times 2 times 3 in the prime factorization of this least common multiple of these two numbers. So this is a 12. So 12 would work. 8 is 2 times 2 times 2. You would need 3 2's in the prime factorization. We don't have 3 2's. So this doesn't work. Let's try another example just so that we make sure that we understand this fairly well. So let's say we want to know, we ask the same question. All numbers divisible by, let me think of two interesting numbers. All numbers divisible by 12 and let's say 9 and, I don't know, let's make it more interesting. 9 and 24 are also divisible by. Are also divisible by. And once again, we just do the prime factorization. We essentially think about the least common multiple of 9 and 24. You take the prime factorization of 9, it's 3 times 3, and we're done. Prime factorization of 24 is 2 times 12. 12 is 2 times 6. 6 is 2 times 3. So anything that's divisible by 9 has to have a 9 in its factorization, or if you did its prime factorization, it would have to be a 3 times 3. Anything divisible by 24 has got to have a 3 2's in it. So it's got to have a 2 times a 2 times a 2. And it's got to have at least one 3 here. And we already have at least one 3 from the 9. So we have that. So this number right here is divisible by both 9 and 24. And this number right here is actually 72. This is 8 times 9, which is 72. So if the choices for this question, let's assume that it was multiple choice. Let's say the choices here were 16, 27, 16, 27, 5, 11, and 9. So 16, if you were to do its prime factorization, is 2 times 2 times 2 times 2. It's 2 to the 4th power. So you would need 4 2's here. We don't have 4 2's over here. I mean, there could be some other numbers here, but we don't know what they are. These are the only numbers that we can assume are in the prime factorization of something divisible by both 9 and 24. So we can rule out 16. We don't have 4 2's here. 27 is equal to 3 times 3 times 3. So you need 3 3's in the prime factorization. We don't have 3 3's. We only have 2 of them. So once again, cancel that out. 5, 5's a prime number. There are no 5's here. Rule that out. 11, once again, prime number. No 11's here. Rule that out. 9 is equal to 3 times 3. And actually, I just realized that this is a silly answer, because obviously all numbers divisible by 9 and 24 are also divisible by 9. So obviously 9 is going to work, but I shouldn't have made that a choice, because that's in the problem. But 9 would work. And what also would work is if we had if 8 was one of the choices, because 8 is equal to 2 times 2 times 2. And we have a 2 times 2 times 2 here. 4 would also work. 4 would also work. That's 2 times 2. 6 would work, since that's 2 times 3. 18 would work, because that's 2 times 3 times 3. So anything that's made up of a combination of these prime factors will be divisible into something divisible by both 9 and 24. Hopefully that doesn't confuse you too much.